Hi guys, we are going to go over the review for the Unit 5 math test today. So what I'd like you to do is I want to make sure that you put your name and number up at the top. And I'm going to go through all of these problems so you can just go step by step with me. If you need to pause it to give yourself more time, you can surely pause this video. Okay, number 1 says fill in the blanks. Use numbers or labeled sketches to show how you got your answers. So the first one we have is 6 times 1/5. That means that I'm going to take 1/5 6 times and add them together. But that's a lot of writing. I need one more to make sure that I get 6 of them. So I can think 1/5 plus 1/5 plus 1/5 plus 1/5 plus. Anyway, it gets me to 6/5, which is the same as, if I can, that's an improper fraction, so I want to make it a mixed number. If 5 pieces equals 1 whole, I have 1 whole and I have 1/5 left over. Another thing we can do to solve this one is we can just take 6 times 1, which is equal to 6, and keep the 5 the same. Okay, letter B, 8 times 2/3. I could write out 2/3 8 times, but remember how long that takes me. Instead, I can just know that 8 groups of 2, 8 times 2 gets me to 16 thirds. That's an improper fraction, so I can think if 3 pieces equals 1 whole, how many groups of 3 can I make? With 16 pieces, I can make 5 groups of 3 and I still have 1/3 left over. Better make sure I circle my answers. Okay. Down here, or for letter C I should say, I have 5/8 multiplied 40 times. I'm definitely not going to write out 5/8 plus 5/8 plus 5/8 40 times over. It'll take me forever. But we're noticing our pattern. I'm taking 40 times 5. 4 times 5 is 20. And I attach a 0. And then I keep that 8 the same. So I have 200 over 8. I can change that into a mixed number. How many 8s go into 200? 25. Okay. Number 2, in Zach's class, 3/5 of 25 students are boys. How many boys are in Zach's class? Show your work. 3/5 of 25. Remember, whenever we see this magic word of, we can replace it with a multiplication sign. So my new problem is 3/5 times 25. I'm going to do the same strategy that I did up above. I can take 3 times 25, which equals 75/5. And I can change that to a mixed number, because right now it's an improper fraction. 15 groups of 5 goes into 75. Or we also know the strategy of, if I have 3/5 times 25, we know this strategy. 25 divided by 5 equals 5. And then I can take 5 times 3 equals 15. Either strategy works. Number 3, Maddie's little brother spilled ketchup on one of her homework problems. So here's her homework problem. 1/3 times something equals a blank. Fill in the bubble to show what Maddie should be able to tell for sure about the answer, even though she can't see the other number. So what should Maddie be able to figure out about the answer, even though she can't see it? So I'm just visualizing what 1/3 would look like. Okay, so I know that I'm taking 1/3 times something. Okay, so that's what 1/3 looks like. Taking it times something, what is my answer going to be? Well, I know 1/3 is less than 1. If I take it by any number, will my answer be less than 1/3? If I take 1/3 times 0, I'm going to get 0. If I take 1/3 times 1, I'm going to get 1/3. So if this is a 0 or a 1/3, I know that my answer won't necessarily be less. I could take it times 2. 1/3 times 2 would be 2/3. So that's over 1/3 already. I know it's not this one. the answer will be less than the ketchup covered number. So whatever my answer is, it's going to be less than what this number is. So I could put a 1 in here. 1/3 times 1 would be 1/3. Is that answer less than this one? Yeah, it is. If I put a 2 in here, 1/3 times 2 would be 2/3. Is 2/3 less than 1/3? Or I'm sorry, is 2/3 less than 2? The answer I put in here? Yeah, it is. What if I put a 3 in here? 1/3 times 3 would be 3/3, which is the same as 1. Is 1 less? Is 1 less than 3? Yeah. So far, that seems to be the pattern. Whatever I put in here, this answer is less than what number I would put under there. So far, I think this one is right, but I'm just going to double check it. The answer will be a fraction. Does the answer have to be a fraction? Not necessarily. We said 1/3 times 3 equals 3/3. That's the same as 1 as a whole number. So it doesn't necessarily have to be a fraction. Or the answer will be greater than the ketchup covered number. We thought that no, that's not working. It seems to be less than. So I'm going to fill in this right here. Okay, so we're thinking that whenever we take one-third times a number, it's the same as finding 1/3 of the number. The answer then has to be less than the number we started with. Okay. All right, let's go to the next page. The back side. Number 4, fill in the blanks. Use numbers or labeled sketches to show how you got your answers. You can use the rectangular array below each problem to help you if you want. I do want you to use this rectangular array to show your work because that's what we've been practicing. So we have 1/4 times 1/2. I know how to do this problem. I know that I can take 1 times 1 and get 1, and I can take 4 times 2 and get 8. I know that's my answer, but I have to prove how I know that. So I'm going to use this rectangular array to show it. If I'm talking 1/4, here's my 1, 2, 3, 4 pieces. Here's 1/4. 1/2 is this much right here. So I'm going to label 1/4 times 1/2, and I'm going to shade this in. Here's how I can prove that 1/8 is the answer. 1 is shaded in out of 8 total. So just like B, too, I know I can take 1 times 1 and get 1. I can take 3 times 4, and that's 12. I know that's the answer, but I need to prove it. So I'm going to prove it by using this array. Here's my 1, 2, 3 pieces. So this is 1/3. Here's my 1, 2, 3, 4 pieces. This is my 1/4. So then I make this a rectangle and shade it in. I've just proven that I've got 1 shaded in out of 12 total. So the answer is 1/12, and I proved it. 3/4 times 4/5. I know I can take 3 times 4 and get 12. And I can take 4 times 5 and get 20. But I'm going to prove this. I'm going to first draw my dimensions for 3/4. 1, 2, 3/4. And then label my dimensions for 4/5. 1, 2, 3, 4. And I'm going to make this a rectangle, shade it in. I've just proven that I've shaded in 12 out of 20 total pieces. I can also simplify this if I want to. I can think of numbers that go into both the numerator and the denominator. I know that a 4 goes into the numerator and a 4 goes into the denominator. So if I take both divided by 4, 12 divided by 4 is 3. 20 divided by 4 is 5. So that's another answer. Okay, number 5. At Kelly's school, 2/3 of the school playground is covered with grass, and 3/5 of the grassy area is baseball field. So I have 2/3 that's grass, and 3/5 of that is the baseball field. How much of the school playground is taken up by the baseball field? Make a labeled sketch to model the problem, use the sketch to solve, and then I have to write an equation to match. So here's what I'm visualizing first. Here's my school playground, so I'm going to draw that. Then with my school playground, I know that 2/3 of it is grass. So here's my 2/3 that I'm going to show right up here. I know that this is grass. Then 3/5 of this is the baseball field. So now I need to take this and divide it into fifths. One, two, three, four, five. I'll go like this across so I can kind of get a good visual for how many total pieces. So, but it's only got to be 3 of those fifths. So right here, 1, 2, 3. So this right here is my 3/5 of 2/3. I can think about how many total pieces I have. So I've taken 2/3 of 3/5. And remember, whenever we see that's our magic word. So we could write 2/3 times 3/5 equals 6. 1, 2, 3, 4, 5, 6 out of 15 total pieces. So 6/15 is my answer. And down here, I'm going to write 6/15 of the playground. I could also simplify this if I want, but I'm going to make sure. Did I make a labeled sketch? Yep. Here's my sketch. It's labeled. Did I solve the problem? Yes. And did I write an equation? Yes, it looks good. All right, number 6. Corey says that 6 divided by 1/2 means the same thing as 1/2 of 6. So the answer is 3. Do you agree with him? Why or why not? Use numbers, labeled models, or words to explain your thinking. So I'm thinking 6 divided by 1/2. I'm going to draw that down here. I'm going to imagine I have 6 squares, and I'm going to divide them in half. This is a half, this is a half. If I take those 6 squares and divide them by half, what do I wind up getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That equals 12. He said it was going to equal 3. Well, let's show 1/2 of 6. If I take half of 6, that's the same as half times 6. And I can just think, I know if I have 6 of something, half of that is 3. So these are not the same. So do we agree with him? No. Because 6 divided by 1/2 equals 12, and 1/2 times 6 equals 3. All right, let's flip our packet over. Number 7, we're talking about brownies, my favorite. There is 1/2 of a pan of brownies left. 4 children are going to share it equally. What fraction of the whole pan of brownies will each child get? We need to write an expression to represent this problem, and we need to use numbers and labeled sketches. Interesting, numbers and labeled sketches to solve the problem. So I'm just going to visualize what this would look like. Oh, and down here we have to fill in our answer. I'm going to sketch out my pan of brownies, my favorite thing to sketch out. And I'm going to show that there is 1/2 of a pan left. So here's my half. I'm just going to shade it in to show that's what we're looking at. 4 children are going to share it equally. So that means I need to take and divide this half between 4 children. And I'm even kind of saying the problem to myself. I'm taking that half and dividing it by 4 children. And if I do that, I'm just going to draw my dotted lines all the way across to see how many total pieces. I know that I have 1, 2, 3, 4 pieces out of 8 total. 4 pieces out of 8 total is what I have here. And then I know that I'm looking at one child gets this, one child gets this, one child gets that, one child gets that. So each child then gets 1/8 of that. 1/8. So I'm going to write that down here. Each child will get 1/8 of the whole pan. I'm going to make sure that I use an expression, use numbers and labels. Well, I drew, I have numbers. I better over here write that this is divided by 4, or I might even just say this is 1/8. I think that's what I'm going to do to show what each piece is. Okay? All right, number 8. Shelly made cupcakes, and now she wants to frost them. She has 4 cups of frosting. It takes 1/3 of a cup of frosting for each cupcake. How many cupcakes can she frost? Okay, so I'm just going to draw. Oh, we have to do the same thing. Expression, numbers, and sketches, and then our answer. I'm just going to draw quick little sketch of 4 cupcakes. So I'm going to use these to represent our 4 cupcakes. Okay, and it takes 1/3 of a cup of frosting for each cupcake. How many cupcakes can she frost? Oh, I'm sorry, this is how many cups. So these are cups. I have 4 cups. I'm sorry, I do this as my cups. I'm getting cups and cupcakes confused. So I have this cup, and I know that I can divide my cups into thirds. Because 1/3, 2/3, 3/3 makes up 1 cup. So if I do that with all of them, I know that there's 3/3 in a cup. This is how much I can use for 1 cupcake right here. This is how much for 1 cupcake. So how many total cupcakes can I make? This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cupcakes. What is my problem? I know that I took 4, or my expression, I know that I took 4 cups divided by each cup. I can split it into thirds. Got me to my answer of 12. All right, let's flip to the back side. We're all done. Awesome. We just have some grid paper. What I would like you to write on the back side is any questions you have for me, any that you want me to go over again. And when you turn this in, I want you to make sure that you write these down so I can take a look, or you can ask me the next morning. All right, thanks guys.